Welcome back, 7th grade math students. We are moving on with lesson 3.5, which comes from Math in Focus. We are going to use our skills with algebraic expressions, and we're going to try factoring those expressions today. So sometimes we want to split our expressions into groups. We will oftentimes consider this the inverse of distribution or expansion, which we learned in our last lesson. So use that idea of expansion or distribution, and we're going to do the reverse of it. We're going to undo it today. So if we take a look at this first problem, we are given 14y take away 30e. Okay, well, to factor something, it means I want to take away from. I want to break it into groups. So I'm really thinking to myself, what divides nicely into 14y and 30e? So I'm actually showing a fraction bar here. I want to divide it up. I need to choose a common factor. So if you remember, early in the year, we worked on some t-charts. I could find the factors of 14, I could find the factors of 30, and I really want to find the greatest common factor, the one that they both share. Well, I know 2 would appear on both of their lists, right? 2 times 7 would work, and 2 times 15 would be great. But there might be something bigger. 3 works for 30, but not for 14. If I keep on going, 7 works for 14, but not for 30. Is there anything greater I could use? How about 5? 5 goes into 30, not into 14. Let's try this idea of 2 and see what we get. In fact, this might be a good hint for you. If you try this t-chart strategy and you notice the numbers across from the common factor, the numbers across from the 2 that they both share, these numbers, 7 and 15, don't share anything else as a common factor besides 1. So it looks like we're on the right track. I'm going to divide both of these terms by 2. So it's like saying I'm taking 14 y's and splitting them into 2 groups. Well, how many y's would land in each group? I hope you say half of 14y is 7y. Next, we want to really take this 30e. We want to split it into 2 groups. You might say to yourself, well, that's not just 30e, it's a negative 30e, and you could treat it that way, and that would be fine as well. So let's talk. What's half of 30? Look over here, it's 15, but this has a variable on it. It's a variable term, so I'm going to get 15 e's in each group. If there was subtraction here, there can still be subtraction here. This looks pretty awesome. But notice, in this process, you forgot to show me that we took 2 out of it. Didn't we take 2 away from both of these terms? We are undoing distribution here. We're undoing expansion. So I'm going to put this in a grouping symbol. I'm going to show you parentheses, and I'm going to show you what I took out. I took out a 2 from both terms. This is what they're talking about with a factored expression. I'm finding the greatest common factor. There it is. We sometimes call it the GCF. And I'm taking it out of all of the terms I'm given. Something that they have in common, I can pull out and leave them, whatever's remaining, in parentheses or in a quantity. Maybe another thought for you is, hey, this is nice. I don't mind that answer. But if you notice, I kind of maybe broke the rule here with my ABC order. Someone else might say, I want to take it one step farther. I want to rewrite that. It's still going to be 2 groups of something, but I want the e's to come first. If you decide to do that, do be cautious. You might want to change your minus to a plus, change the sign of next. This really is a negative 15e. And we are adding now. We changed to addition. We're adding 7 y's to it. This looks pretty good. This might be even a better or stronger answer. All right, we're going to try another one here. This one still has 2 terms, but gosh, they look different, don't they? Notice I have a negative y take away 8. Well, first of all, I have to be honest with you. I'm missing a coefficient here. I'm not sure what could go in front of this y to represent a negative y. Well, it's like having a negative king. How many kings do you see here? Just 1, and he's grumpy. We will show the negative coefficient. It's a negative 1y is what we're really dealing with here. And I can take away 8 from that. This looks better already. This looks more like 2 terms to me. But I'm a little bit concerned yet because notice I have this subtraction here. And it's hard to see that a negative 1 and an 8 share much in common at all as far as common factors. Maybe if I tried that rule that we used early in the year where I change the minus to a plus, change the sign of next, I could see something that they have in common. I'm looking for a common factor. Well, I don't really need to build those t-charts like I did last time, I don't think. What I notice is that not much goes into 1 at all, so not much goes into negative 1 at all. And I do notice something else. You're going to start looking for all negative terms. So if you see that all of your terms are negative when you are factoring, there's a big clue. It means divide by a negative. So we need to do that now. The only number that these really share as a common factor is a -1. So I'm going to pull out -1 from each of those. Oops. And I didn't show it the same way as last time or the same way as Math in Focus, so let me erase for a quick second. We're going to take away or pull out the common factor of -1. All right, here we go. How many times does -1 go into -1? The answer is 1 time. Those signs get along. But notice it's a wise guy. He has a variable term. Make sure he has his identity. Now, we're not done yet because I divided the first term by -1. I need to make sure I do the same thing to the second term because we are factoring today. Well, -8 divided by -1 gets me a +8. Those signs both hate Brussels sprouts. They get along. All right, I end up with 2 positive results. What is happening between those 2 terms? If you remember, I looked back, I saw that there's some addition there. I made that an addition. I'll keep it an addition. And while I have this pretty close to done, I need to show you where that -1 goes. Where does it show up in our expression? Oh, we're going to factor it out. We're going to show it in front of parentheses. We are undoing distribution. So I'm going to show you what the distribution would have looked like. I put a -1 out front. Oh, this is an okay answer. Hey, yay, you got yourself a smiley face. But take a look. I noticed something, some unnecessary notation. What's something that we could get rid of? Ah, someone says, get rid of the coefficient of 1. It means the same thing as just a plain old y. 1y is the same as 1y without the 1 showing. All right, and the +8 is still happening. Parentheses have to stay there because this is a group. And I pulled out that -1. Oh, yay, maybe you're like, hey, this looks better already. Yay, you got your second smiley for the day. Why are we not done yet? There is something else that we could simplify. We could make look a little bit cleaner in a cleanup step. And if you notice, there's only one thing that we could get rid of. I can't get rid of the negative. That would change the values. I can't get rid of the y. Then I won't have any y's. Can't get rid of the 8. Ah, what I can get rid of is this 1. Do you know how we put in those implied coefficients when we start working with our math? We had to write that coefficient right in here, didn't we? We had to say, hey, what number goes there? And when I'm doing the reverse, when I'm getting ready for a final answer, I get rid of anything unnecessary. This is the same as the negative quantity, or the opposite of the group y plus 8. Ah, this is your strongest, most algebraic answer for this problem. And again, we're factoring. If you take a look, there's a way to check these. There's a way to go back and say, hey, does it actually turn into the original problem? So you could grab any step in here that we did and just check. Well, this negative up front really means a -1. It's like right here, it's like saying -1 times y would get me a -1y. And -1 times 8 would get me a -8. Oh, that actually was the original problem. It checks out. Go back to this last one. Let's do a quick check. If I took this 2 times a -15e, 2 groups of -15e would get me -30e. Oh, I kind of see something like that up here. Close, -30e. I'll just write it down so I keep track of it. How about this? If I distributed one more time, would it check out? What's 2 times 7y, or 2 groups of 7y? Sounds like I'll get 14y. Notice there's addition here, so I've combined them. Is this really the same as the original problem? Oh, indeed it is. We just did a rewrite step. We just changed the order, didn't we? Ah, this looks pretty good. So one way to check if your factoring is correct, go ahead and try that distribution. Take your final answer, see if the distribution checks out and gets you back to the original problem. If it does, you're good. Next up, I want to take a look at this third problem for a couple of reasons. The numbers are a little bit bigger, and I want you to be aware that if you don't grab the GCF, your answer might still check out, but it wouldn't actually be in a final factored form. So I noticed something here. The subtraction could be trouble. Let's change a minus to a plus, change the sign of next. And now I'm trying to think of the greatest common factor that goes into both. Oh, cool, they're both even. Let's take out a 2. All right, if I were to do that, I know the 2 is coming out of both terms. I put that 2 in front of parentheses. 2 goes into a -48, -24, y times. 2 goes into a -16, a -8x times. And there was addition, there still is addition. Oh, you could go and check this out all day. You could go ahead and say, 2 groups of this and 2 groups of that, it checks out. But I'd have to say, I'm sorry, you're not quite there yet. And this is why we say that. What type of number do I want you to factor? I want you to ask yourself, is it the greatest common factor? Notice I've got a problem here. 2 is a common factor, but it's sure not the greatest. And I know that because when I look inside, they still could be divided by something else they have in common. Oh, I also noticed something else. They're both negatives. I shouldn't have pulled out just a positive 2. If anything, I could have tried a negative 2, but I still wouldn't have had the greatest common factor. So it's very tempting to grab the first thing you see as a common factor, but I want you to think a little bit beyond that. Make sure you have the biggest number, the greatest number that they both share. I'm going to try some quick t-charts for 48 and 16. I am kind of ignoring the negative issue right now, just to make sure I have my facts down. 1 times 48, 2 times 24, 3 goes in there, let me think. 16 times, 4 times 12 is good. I think I can squeeze a 6 times 8 in there too. All right, let's look at 16. 1 times 16 and 2 times 8 and 4 times 4. I think I got them all. How would you find the greatest common factor using this strategy? Well, you would go and ask yourself, what do they have in common? They both have 1s, but is there anything bigger? We're at the auction now. Oh, 2 going once, going twice. No. 4, they both have a 4. 4 going once, going twice. Are we? No, we're not done yet. I notice on the other side here, there's an 8, and there's an 8 here. 8 going once, going twice. Oh, you wish. Take a look. 16 going once, going twice, sold. What I mean by this is 16 is really the greatest common factor. We really need to do some rethinking here. We have to make sure that whatever I decide to factor out is the greatest, the biggest common factor that will work for both numbers. So for this problem, the GCF is 16. That's what I'm going to divide by. If that's how many groups I'm making, I show that as a number of groups. I put it in front of parentheses. I show it in front of a distribution. All right, well, take a look. 16 does go into 48y. Go back to your t-chart if you like. 16 times what? 3 gets me 48. The bummer is I want a negative 48, so cling on to that negative. And notice it's a variable term, so we also get this y. It's still a wise guy. Or I'm getting negative 3 y's in each group. The next piece of this says divide the second term by 16. Well, 16 goes into negative 16 a negative 1 time. Negative 1, and it has a variable, so I have to make sure he's still an X-Man like Wolverine. And if there was addition, there's still addition. Now, I'll be honest with you, you can check this one out all day too. You can multiply 16 times this and 16 times the second term, and it would check out. But we're not there yet. Does anyone remember the rule that we're forgetting? Notice, think back. We had a suggestion here in the middle that will also be in your class notes. When all of the terms are negative, I need to divide by a negative GCF. Divide by a GCF that's negative. So how can I fix this up a little bit? Instead of dividing by 16, I could take out a negative 16. Ah, yeah, that's the common factor I'm looking for. It's the greatest common factor, and it's negative because all terms are negative here. Well, that's going to change things. Negative 16 times negative 3y would get me, the wrong thing up here. Get me a positive 48y. So how's that going to change this? This would have to be a positive term instead. Positive 3y times negative 16 gets me the negative I want. Good. How about this next one? Negative 16 times a negative 1x. Oh, that'd get me a positive 16x. This is no good. So I need to rethink that. I know that I have to pull out a negative because all terms were negative. So this GCF is good. What's not good? This negative 1x should be positive. See how that kind of changed things on you? You have to be really careful. So it probably would have been wiser to notice all terms were negative and divide by that negative GCF right from the get-go. All right, let's do a cleanup step because this is looking kind of messy to me. I have negative 16 times the quantity of 3y plus 1x. Oh, that looks better already. I like it. If you can get this far, I say, awesome, you earned your smiley. Oh, there must be more. Take a look. What sort of things do you notice? Well, I can't get rid of any implied coefficients, or can I? The 16 can't go. and the negative sure can't leave. 3 has to stay the coefficient of y, but look here, 1x. How could we neaten that up? Oh, you could just write x. I see one of them. There it is. We'll bring everything else down. And don't forget that negative 16, that's a negative GCF. Hey, maybe you got here and I say, awesome, second smiley. Why are we not done yet? Seriously, let's find a final answer. What is the one thing I'm missing to call this a final answer and feel like a millionaire? Oh, ABC order with your variables. This negative 16 is still my GCF, and it's good. But x comes before y in the alphabet. This should say negative 16 times the quantity of x plus 3y. We're really practicing getting some good communication and notation so that when you look at someone's work and someone's answer, you can see that it has the same meaning. In fact, a final answer should kind of be identical on your paper or mine. How could I check this out to see if it works? Did I get the right final answer? Well, you would just distribute. See if negative 16 times x gets you the original piece of the problem. See if negative 16 times 3y gets you the original piece of the problem. And if I can scroll up here, I think it does. Let's think about that real quick. Negative 16 times x is a negative 16x. Oh yeah, it's sitting right here. I see it. This matches. And a negative 16 times a positive 3y gets me a negative 48y. Ha ha. Final answer. I'll give you a gold star. It's been a lot of work today. With that, we have learned how to factor algebraic expressions. Oftentimes we need to do this sort of thing if we're breaking something into groups. We're trying to figure out how many groups we can make out of a whole or out of the total. So notice in the first one, I just had to find the GCF. That's what we worked on here. And then it got a little more complex because I wanted to think about ABC order with my variables. Found a final answer. Oh, the second one, we had an implied coefficient. I had to show that that negative y was really the same as negative 1y. And when you have multiple negative terms, you pull out a negative GCF. We did that again over here, didn't we? And I showed you the importance of getting the GCF out of there. You might get the same result in the end, but final form with factorization means the greatest common factor. No more common factors could be pulled out besides 1. The last thing I want to do with you is show you some examples with 3 terms. So if you take a look, we're going to try to factor these expressions in 3 terms. So the first one, I have G's, H's, and 66, a constant, oh my. What could I do to take out a common factor of all of them? Well, first, I'll tell you, I don't like these subtractions sitting here. So I'm going to change the minus to a plus, change the sign to next, or add the opposite, if you will. I know I want to divide them into a group, or groups, as many as I can make. So I'm looking for a common factor of all these numbers, the coefficients and the constant. I noticed something. Digits are the same, 3 and 3, 1 and 1, 6 and 6. Aha, big clue. 11 will go into all of them. Now hold up a minute. You might want to ask yourself, are all the terms negative? Yeah, 2 of them are. One of them is not. So I'll pull out a positive GCF. The only time we pull out those negative GCFs is if all of the terms have negatives. All right, I'm making 11 groups out of all of these things. I'm going to save a lot of room in my parentheses or my quantity or group. 11 goes into 33G, 3G times. 11 goes into this negative 11H, a negative 1H time, negative 1H. 11 goes into negative 66, negative 6 times. And notice I changed all those subtractions. The only thing I have to bring down here are additions. And if you can get me this far and double check that you have the GCF pulled out, I'm happy. You got yourself a smiley. But why aren't we done? Seriously, is there more to be done? Oh, we're not in final answer. There's something that we could simplify or clean up. So what's something you see in our answer that maybe we could eliminate or change or clean up a little bit? I hope you're looking right here. I see a negative 1H. Haha, we saw this a little bit ago. I can keep everything else the same, but instead of a negative 1H, I can write a negative H. Means the same thing. I can take away that coefficient and just show it in an implied way. It's like invisible ink. There we go. Remember, the only coefficients that works on are 1s or negative 1s. All right, let's see here. This looks pretty nice. I like it. In fact, I'll give you a smiley for that one as well. Why is this not done yet? Is there more to be cleaned up, fixed up, simplified? In fact, there is. If you look, the last thing I notice, I check for ABC order. It looks pretty good to me. G comes before H in the alphabet, but I see something. I see that magical combination that we've talked about before. When there's an add a negative or add the opposite happening, I can change that to subtraction. I can change the next one as well. It's got that same combination. I want to bring everything else down the way it is. Notice that H is sitting alone right now. These two symbols combine to make that subtraction. Look here. Plus a negative really is the same as subtracting. So I'm going to subtract 6 at the back. And this 3G, well, he never changed. He's still a positive 3G. These parentheses, they have to be there. This is showing this is what belongs in the group or the quantity. And how many groups did we make? 11. Huh. You just earned yourself the best color ever, purple star. All right, we have another one to peek at. I'm given 3 terms and I'm looking for the GCF, the greatest common factor. Well, what's something that divides into 18D, 9E, and 12? You can make your T-charts off to the side. 3 of them would be needed, but I noticed something. 2 will work for only 2 of the numbers. Ooh, 3 would work for all of them. Is there anything bigger than 3? Not that I see. 9 goes into 18, but it sure doesn't go into 12. 6 goes into 12 and 18, but not into 9 nicely. We're going to try 3. Let's see if the GCF here is actually 3. That means I'm going to try to split it into 3 groups, give myself a nice grouping symbol or parentheses here, and I say, what's 18D divided into 3 groups? 6D. Don't forget your variable. Make sure it looks like a D and not some strange number, okay? What about this? Does 3 go into 9E? Sure does. 3E times. Notice I'm trying to show you these variables. They stay lowercase, a little bit smaller so that you can tell what they are. Next up, does 3 go into 12? The answer is yes, it goes in there 4 times. What's happening between all these terms? Addition and addition again. Woo! We got there. In fact, I'd give you a smiley for this one. Nicely done. And if I notice 6, 3, and 4 don't share any other common factors, this looks pretty good. But how do I clean it up? Are we okay with implied coefficients? Are there any to rewrite? Any 1s or negative 1s to deal with? No, things look good. How about this? Check out your variables. Are your variables in ABC order? A, B, C, D before E. Oh, that's good too. And the constants are at the back. Yeah, we save those for last. This looks nice. So what about that combination like we had a minute ago? What about adding the opposite or plus a negative? Do we have any of that happening this time? No, we do not. Not only did you earn yourself a smiley, you earned yourself an orange star, meaning this is the final answer. It's both. This one didn't require as many steps. We didn't have as many negatives to work with, no implied coefficients like we saw in the last one. This just seems to have our final answer in place. How would you check this? Just food for thought. You take 3 and distribute it. You would expand across the whole expression and see if it checks out. 3 times 16D, 18D, check. 3 times 3, 3E, 9E, check. 3 times 4, 12, check. It would take you back to the original expression. It just has been factored. We've just split it into an equal number of groups. The greatest number of groups we can make. When factoring expressions, remember to grab the GCF. Also remember to look for all terms being negative. In this case, 2 terms were negative. All 2 of them were, so we divided by a negative GCF. Don't forget to show those implied coefficients along the way, and if you don't see any common factors, the best you might be able to do is a -1. Pull that negative out of all the terms when possible. With this, I hope that factoring expressions is really, really similar to you, to our distribution or our expansion. You can see how they're connected, how they're opposites or inverses. And I want you, again, just to be really careful about your notation. Consider how to get yourself to that final answer or that mastery step when you can.